So in this part, we're going to do some more factoring, but there's some certain type of factoring that you can do to help work it out, and it won't be that hard. Now, this, our A value, is not 1, and you would assume to use the divide and move method. In some cases, you don't have to. And here's why. We're going to talk about factoring by greatest common factor, or GCF. So when you have in a quadratic equation where A is not 1, you check if you can divide all terms, your quadratic term, your linear term, and your constant term, or basically A, B, C. You check if you can divide by a common number. My lowest common number is 3. So you can definitely divide 3 by 3. You can definitely divide -6 by 3. That would become -2. You can divide -45 by 3, which would become -15. So my greatest common factor, which is 3. So again, I repeat, you are able to divide the quadratic term, or the A, the linear term, or the B, the constant term, which is the C, all divisible by 3. Now, I use 3 because that's the lowest common number to check, and I repeat, to check if you can divide all 3 terms by the same number. In this case, you can. So if you can divide, that means you don't have to use the divide and move method. So I repeat, if you can factor by GCF or divide by the common number, you don't have to use the divide and move method. Now, when you're factoring, it means that you're dividing. So remember foiling. When you're foiling or doing the box method, you're doing multiplication. Factoring is the opposite, which is division. So I'm going to write right here. Foil is the opposite of factoring. So remember, FOIL is multiply, which is opposite divide. So again, with FOIL, you have to multiply. While you're factoring, you're dividing. So what I'm going to do is, I'm going to divide all 3 terms by our common number 3. Now our GCF, our common number, will always go outside the parenthesis. So repeat, your common number always goes outside the parenthesis. It never disappears. The reason I say it never disappears because sometimes you might have to use that number. Some cases, you don't have to. But in your best interest, just to be safe, always put it outside the parenthesis. So what I'm going to do is, 3n squared divided by 3 will simply be 1n squared, or just n squared. Negative 6n divided by 3 will be minus 2n. Negative 45 divided by 3 will be minus 15, and then equal 0. So repeat, anything that you divide by a common number will be on the outside of the parenthesis. When you divide, whatever you get as your result goes inside the parenthesis, just like that. So from there, I'm just going to factor this quadratic equation. Don't worry about the 3. Just the quadratic equation. So my A part is 1, my B is -2, and my C is -15. So the top, which is A times C, so 1 times -15 will be -15. My bottom was B, which is -2. So for factors of A times C sum and difference. Alright, so factors of negative 15. I can do 5 times negative 3. If I were to combine these two numbers, positive 5 and negative 3, it would be sum and difference would be positive 2. Not exactly the same. So what I'm going to do is I'm going to switch to negative. So negative 5 times positive 3. These two will multiply to negative 15. And if I combine negative 5 and 3, the sum and difference will be negative 2. So it matches. So those are the correct pair of factors. So I'm going to write negative 5 here and positive 3. So once I get the correct pair of factors, I'm going to write in factor form, just like before. So x minus 5 times x plus 3. Now don't forget, I had a common factor, which is 3, so I'm going to put it outside of parentheses, equal to 0. Now, I'm not going to have euphoria in this video, but I always recommend that after you get in factor form, you FOIL or use a box method to double check that these factors are correct. So again, I'm not going to FOIL to double check here. I do recommend that you FOIL or use a box method to double check if the factors matches with your quadratic equation. Alright, so we're going to skip to the checking part. We're going to move on to solution. For the solution, we're going to set each factor equal to 0, mainly the ones that with x. So I don't have to worry about this 3 here. So the ones that I have left underlined, x minus 5, x plus 3, just going to set it equal to 0. I'm going to solve for x on this one, so plus 5 on the left, plus 5 on the right. So x equals 5. Here, minus 3 on the left, minus 3 on the right. X equals negative 3. So, for this example, my final answer is x equals 5. And x equals negative 3. So those two are my solution. Now, be very careful. If I were to ask you, just give me the factor form, this whole thing would be your answer. So the 3 on the outside, x minus 5, and x plus 3, that will be your final answer if I ask you for factor form. Example 2, again we see that a is not 1, so check if you can factor by GCF. So of my 3 numbers, 5, negative 15, negative 50, the smallest number, many not worrying about the sign, the smallest number is 5, so I'm going to check if I can divide each term by 5. 5 divided by 5, that can work. Negative 15 divided by 5, that can work. And negative 50 divided by 5, that can work. So, I'm going to divide by 5, meaning factor by GCF. My common number will be outside the parenthesis. And then now I'm going to divide each term by 5. So 5p squared divided by 5 simply be p squared. Negative 15p divided by 5 will be minus 3p. Negative 50 divided by 5 will be minus 10 equal to 0. Alright. From that point, we're just simply going to factor what's inside the parentheses. So p squared minus 3p minus 10. Now my a is 1, my b is negative 3, and my c is negative 10. So my A times C, 1 times negative 10 will be negative 10, and my B is negative 3. Alright, so let me write out factors of A times C. And sum and difference. Alright, so negative 10 and then negative 3. So factors for negative 10, I could say negative 5 times negative 2. My sum and difference between these two numbers is a positive 3. So it doesn't exactly match with my B. So what I'm going to do is I'm going to switch to negative. So negative 5 times positive 2. That will be negative 3 for the sum and difference. So it matches. So these are correct factors. So I'm going to write negative 5 here and positive 2. Now I'm going to put in factor form using these numbers, negative 5, positive 2. So it's going to be P minus 5, P plus 2, and I'm going to have my common factor on the outside equal to 0. So that is my factor form. And again, we're going to skip the checking our factors with FOIL or box method, but I highly recommend that you do it on your work. So what we're going to do is set the factors with the P variable equal to 0. So P minus 5 equal to 0, P plus 2 equal to 0. So the first one, P minus 5, I'm going to add 5 on the left, add 5 on the right. So P equals to positive 5. This one, I'm going to subtract 2 on the left, subtract 2 on the right. So P equals to negative 2. So those two would be our solution. P equals positive 5 and P equals to negative 2. But my factor form would be this. 5 times P minus 5 times P plus 2 equal to 0. That would be your final answer for factor form. If I were to ask you with the solution, then these two, P equals 5 and P equals negative 2, those are your solution. In our third example, we have 3n squared minus 21n plus 36. And we're going to check if you can factor by GCF. My lowest number of all three, 3, 21, and 36, I'm going to use the 3. So I'm going to check if I can divide each term by 3. The first one, 3 divided by 3, that can work. Negative 21 divided by 3, that can work. And 36 divided by 3, that can work. So I can do factor by GCF. I'm going to divide all three terms by 3. So my common number that I'm dividing by, these 3 in orange, will be on the outside of the parenthesis. So again, outside of the parenthesis. 3n squared divided by 3 simply be 1n squared or just n squared. Negative 21n divided by 3 will be minus 7n. Positive 36 divided by 3 will be plus 12 equal to 0. Then I'm going to factor n squared minus 7n plus 12. So my A is 1, my B is negative 7, my C is positive 12. And then our X table, so my A times C, 1 times 12 is 12, and my B is negative 7. Now, factors of A times C. And the sum and difference. So factors of a times c. For positive 12, we could do 2 times 6. When you multiply, will be 12. But if I combine a positive 2 and a positive 6, the sum and difference would be positive 8. Doesn't match, so I can't use 2 and 6. Let's do 4 times 3, multiply into positive 12. The sum and difference between these two numbers, positive 4 and positive 3, will be positive 7. Doesn't exactly match with our b, so since we're looking for factors of positive 12, you can also use negative 4 times negative 3. Two negatives will multiply and become positive. And then when I do the sum and difference between negative 4 and negative 3, it will become negative 7. So these two sum and difference and b values, they match it, so therefore these two factors are correct. So negative 4 and negative 3. Once you find the correct factors, I'm going to put in factor form. So I still have my 3, my GCF, on the outside of the parenthesis. First will be my negative 4, therefore n minus 4. And then the second one, negative 3, so n minus 3. So I have my answer in factor form. Again, I'm going to skip the checking the factors, but you should always do it in your work. And then the only ones I'm going to set equal to zeros are the one that has the variable n. So my first one, n minus 4 equal to 0. The second one, n minus 3 equal to 0. So the one on the left, n minus 4, I'm going to add 4 on the left, add 4 on the right. So it's going to be n equals positive 4. Here, the one on the right, I'm going to add 3 on the left, add 3 on the right. So it's going to be n equals to 3. So my final answer, or the solution, is n equals positive 4 and n equals to positive 3. So those are your two solutions. Now again, if I ask you for factor form, it will be this one right here. 3 times n minus 4 times n minus 3. That will be your final answer for the factor form. But if I also ask you to find a solution, you include n equals 4 and n equals 3.